Everybody, thanks for joining me today. My name is Emma McGrattan and I'm SVP of Engineering at Actian. While I tell you a little bit about myself, I thought I'd put some much more interesting facts on the screen. So I'm SVP of Engineering at Actian with responsibility for our Vector in Hadoop product, which is what you're going to hear about mostly today. I've been doing database for over 20 years. Back in my day, we used to call it data, and now it's big data. Back then, big data was something that wouldn't even make a dent on your iPhone today. So what I want to talk about is, first off, to introduce you to Actian. We are relatively new in the Hadoop space from a SQL in Hadoop perspective. We introduced our product to the market last June. We've spent many years investing in database technology development, but re-platforming the database for Hadoop was something that we completed last summer, and we've had very good success with it to date. We generate about 140 million in revenues a year. We're profitable. We've got over 10,000 customers around the world. We have 8 offices worldwide, and we provide 24/7 follow-the-sun support. So if we have a customer in Australia that hits a challenge running their systems and they need help through the night, that issue will transition to our European and North American team. So very well positioned to provide enterprise support for enterprise application deployment. The analysts love us and have lovely things to say about us. And this is just a sampling of some of our customers. Those of you with good hearing can probably tell that I'm Irish. The Irish Revenue, which is the equivalent of the IRS in Ireland, runs all of their systems on our technology. So they run our Vector in Hadoop product for tracking down people who are spending more on their credit cards than they're claiming they're making in income. So we have a remarkable customer base, some very large deployments of our technologies. And we have a very satisfied customer base too, with our customer satisfaction ratings above 95% consistently. You will have been harangued by some women as you entered the room to give you some keys. It's because we're anxious to give away an Apple Watch. To get a watch, you need to collect 5 keys. So in your bag that you got when you registered, you would have got something that looked a lot like this. At the bottom of that was key 1. And as you came into the room today, they will have given you keys 4 and 5. If you didn't get them, you can see them as you leave the room because they've got plenty of keys left. And then to get the other 2 keys, because you need 5 keys to enter the drawing, you need to come and visit our booth, talk to some Actian people, see our demos. And we have this wonderful machine that just blows cash up at you and try and collect as much as you can. So it's kind of fun too. So we're looking at fun ways to educate you in our technologies and what we're all about. The Apple Watch is being given away on Thursday in Mike Hoskins' session. And Mike's talking about how Hadoop is now ready to serve your EDW workload. So I've forgotten the exact title of the session, but that's essentially what Mike's talking about. So, as you came into the room, you probably saw that your seats were wallpapered with some Jethro Data literature. I don't know why that is, but it's kind of coincidental because I came across Jethro Data just last week. And we have this chart that we've been using for a year now in plotting out the SQL and Hadoop landscape. And when Jethro Data came on my radar last week, I gave them their own category. So they're down here in the bottom left-hand corner of the slide. And the reason I did that was, and in their poorly proofread collateral, what you'll see is under easy to set up, they start by saying, just install it on a dedicated server or 2, right? So they're off of Hadoop, right? You point to your Hadoop cluster. So in our graph where we talk about Hadoop integration, I'm annoying myself with the noise here. With our graph of Hadoop integration, I put them kind of off the low side of things because they're not integrated with Hadoop. They connect through to Hadoop. And in terms of SQL maturity, Jethro Data is very low. And we have a fairly low bar in SQL and Hadoop solutions for SQL support, as evidenced by the fact that everybody's rewriting the TPC DS queries to show how clever they are. And the Jethro Data needed to rewrite the Impala TPC DS queries because they couldn't support some of the SQL 92 syntax that was used. But anyway, that's Jethro Data. And is anyone here from Jethro Data? All right, maybe I'll visit their booth later. I have no idea why they did that, but they did what they did. All right, so that's them. Up on the top left of the slide there under the word that says hi, what you see is the more traditional EDW players, right? So it's Vertica, it's Teradata, it's the SQL Server, Enterprise Data Warehousing Solutions. These guys have very rich SQL support. They have very good knowledge of how to deploy enterprise solutions. They're secured, they give give you all of the bells and whistles that you need when you're running 24/7 operations. But they connect through to data that's in Hadoop. They don't have that native Hadoop integration. They have these connector technologies where they'll reach out, they'll get the data that's needed to satisfy the query, they'll pull it back into a secondary cluster, and they'll run the queries against that. So in terms of their maturity, in terms of SQL support, operational support, really high. In terms of Hadoop integration, very low. Then we have the wrapped legacy players, and in here I'll put players like Splice Machine and Hadapt and Hawk. They've taken typically a Postgres solution, although that's not true of Splice Machine. They take a Postgres solution or an open source database solution, and then they find a way of using its SQL capabilities, and then they'll take the queries and run them against data that's in Hadoop. So in terms of Hadoop integration, they're running in Hadoop. In terms of their maturity, they don't have the full richness of the SQL language, but they're getting there. And then the third category I have over here is the Cloudera and the Hive and the IBM guys, where we call these the from scratch players. So these are the people that set out to build a solution for Hadoop. Now, one of the challenges that they face is that you can't build a database overnight. It takes decades and many gray hairs, as I can show you. So doing things like understanding distributed query optimization, it just takes years to figure the whole thing out, to understand all of the nodes that you've got in the environment, their peculiarities, whether you've got a slow network link, just understanding the heuristics of your data. It takes time to work through all of that. And what you'll see within these technologies is that their SQL support is not great. Their understanding of operational support from a security and a 24/7 operations perspective is not great. But we admire them for their guts, right? They're building these solutions from scratch and putting them out there. So in terms of Hadoop integration, they're fairly high. In terms of their product maturity, as I say, it takes decades to get there. And if you look at the players in the EDW space, in Vertica and Teradata and in Microsoft, and Oracle would be in there as well. These guys have been around for decades and building these technologies for hundreds of investments or thousands of years of investment. So then we have this very clever box that only we sit in, right? And that is because we say we're truly integrated into Hadoop. We've got the maturity that we've learned over the years in supporting enterprise database deployments, right? So if you're familiar with the ParExcel technology now called Matrix, that's one of our technologies. If you're familiar with Ingress, which runs businesses around the world, that's a technology. pSQL in the embedded database space, that's one of our technologies. Vector for the performance and analytics space, that's our technology. So we understand performance, we understand database deployments, and we understand supporting enterprise deployments. So we've got the maturity, and we've got the native Hadoop integration. So what we offer is quite unique. Now, I want to talk a little bit about Vortex, because that's what all of our marketing material talks about. Vortex is a combination of two technologies. And if you'll bear with me, I'll explain this chart for you. At the top of the screen, we start with a technology that's called Actian Data Flow. And this is an analytics workbench that allows you to point and click, and you can truly build amazing workflows just dragging and dropping these things onto your desktop. And we have some demonstrations of this in our booth. But essentially what I can do here is I can say something like read data from any given data source. It can be a Hadoop source, it can be a database off of Hadoop, it could even be a PaaS application that you're running. So you read your data source, you can do all kinds of blending and enrichment of that data. You can do some data science, some analytics, run k-means algorithms, whatever you choose on that data. And then in this example here, we load it into Actian Vector in Hadoop. So really nice data flow, desktop, point and click, easy to use design. And when the data comes into Hadoop, we have in our architecture here, the Vector in Hadoop architecture has Vector running on a master node, and then it communicates out to all of these data nodes. We've done some very clever things in deploying Vector in Hadoop, taking advantage of some of the capabilities that are native to Hadoop, such as block replication, right? So one of the things that we decided was if you're joining two tables, table A and table B, and you're joining them on a column where they're not partitioned for the blocks of the tables to be co-located because you've used a different partitioning scheme, we'll actually use the block replicas to satisfy that, that join and avoid the need to communicate between the nodes. So very clever in thinking about what are some of the benefits that we can get from some of the inherent goodness that Hadoop provides as a big data platform, and that was just one of them. So when you see later on in the slide deck, and when we're comparing our performance with that of Impala, what you'll notice is that for any queries that have very rich or complex joins, will significantly outperform Impala, because we do some very clever things. As I say, it comes from our background in understanding exactly how to run distributed databases. So that's the architecture here. We then also have a data flow component that can run within Hadoop for doing some high performance data science and analytics. So if you want to learn more about the data flow components, do visit our booth. There's some great demos there. I'm a database person and I can play with it, but talking about it in depth is something that I can't really do. So I want to talk about what's unique about the Actian vector and Hadoop technology. And when I do this, I'm aware of the time that I've been given today, so I just picked the top 6 things to talk about. So the first is vector processing, and that's where the name Actian vector comes from. So vector processing, for those of you who aren't aware of it, a vector is an array. You can think of a vector as an array. And in a traditional database, if you were to do something like, say, everybody who's in this room today deserves a 20% pay increase, right? In a traditional database, you'd go through your employee table, you'd go to the salary column, and you'd multiply record at a time by 1.2, and that would take however long it took. When you're dealing with vector processing, we're smart enough to take an array of values. So we would go to that same employee table. We would take an array of 1,024 salaries. We would load those into the register on your CPU and multiply that by 1.2 in a single clock cycle. So in terms of the time it would take us to perform that same operation on your data, it's going to be a fraction of the time that it takes the traditional databases, because we're using the fact that vector processing is built into modern CPUs. There's a technology that you may have heard of referred to as SIMD, single instruction, multiple data, and that's what we're doing, right? So we've got a single instruction, in this case it's multiplication, multiple data is this array of values, or this vector of values that we're using. We store all of our data in compressed vectors, because what we find is that since we're going to be operating on vectors at a time, it makes sense to store them in that way, and that way we can get them through the system as quickly as possible. The next thing that we do that's quite clever is to exploit chip cache. So a lot of the, when I talked on that previous slide about the enterprise data warehouse technologies, those guys all date back to the 70s, the 80s, and the 90s in terms of their architecture. And they were designed at a time when disk was incredibly slow and fairly expensive, and memory was scarce, right? You just couldn't get memory. You needed to account for your use of every byte of memory in the system. So in those systems, everything that they try to read from disk, keep everything in RAM, and then they bring it into the CPU for execution. And what we've done is, because our database has been designed in the more recent times, we've recognized the fact that the modern CPU has a few megs of onboard chip cache built into the CPU, and we leverage that. So instead of being constrained by the speed of memory, we're using the onboard chip cache. Now, those of you who chose to sit down in the back today can't read any of the numbers on my slide, so you're going to have to trust me here. But what we have going across the bottom of this this point 2 here in the graph that we're displaying is the amount of data that can be processed in a second, right? So we're dealing with disk, you're talking about 40 to 400 megs. We're dealing with RAM, you're talking about 2 to 3 gigs. We're talking about the chip cache, you're talking about 10 gigs. On the y-axis here, we have the number of clock cycles it takes to process. And we're dealing with chip cache, you're on about 2 to 20 clock cycles. In RAM, you're on about 150 to 220. And disk, you're talking about millions of clock cycles to get the data from disk and into the CPU cache and your queries executed on it. The third point that's important about understanding vector is that we're a column store, right? So analytic databases tend to be column stores. It makes the most sense. Typically when you're running analytics, it's on a column of data at a time. You don't want the overhead of having to read all of the rows. You want to just focus on the columns that are of interest to you, right? It might be salaries, it might be the balance on your savings account, something like that. We call ourselves a second generation column store because all of the first generation column stores had real problems with updates. And one of the ways that they've solved that challenge was they implemented a read store and a write store. So as you're updating the data, the changes get written to the write store, and then over time that write store becomes the read store, and you start a new write store. It's a challenge, right? We came up with a very smart technology that's called a positional delta tree. And what it is essentially a memory overlay where we keep track of the position of the changes to your data. And as you're referencing data that's been updated, we're able to refer to the memory overlay. It's a tree structure that's only ever 3 levels deep, and we can very quickly get to the updates in your data to the point where you wouldn't even notice that updates were happening in a system where you're running queries. So quite a challenge to overcome, particularly in Hadoop, right? So we'll talk a little bit later about some of the challenges in dealing with HDFS because it wasn't designed to support things like random access and data updates, and it's something that we've solved. And the next thing is we've really smart compression algorithms, and they're smart in that we can, in looking at data types, they each require different compression algorithms. So you might have something like a packed decimal will compress quite differently to character data. And when you're dealing with character data, you might have something that has a lot of trailing blank space, right, which is going to compress differently than its very packed data. So what we do is we look at the data type, and we'll choose a compression algorithm family based upon the data type, and then we actually look at the block of data and say, this is the most appropriate algorithm to use for this particular data block, and that's what we use to compress the data. So we typically see a 5-to-1 compression ratio, which is pretty good, and which, given that typically we'll see a replication factor of about 3 on HDFS, it kind of counters the fact that HDFS kind of bloats your disk requirements. We also use storage indexes. So for those of you who took the time to read the Jethro Data stuff, that's their one-trick pony with indexing. It's one of the 6 things that I pointed out here before I even knew Jethro Data were paper in the room. So in terms of our storage indexes, what we do is, as I mentioned earlier, we store data as compressed vectors in blocks on disk. And for each block that we're storing on disk, we keep track of what's the minimum and maximum value for that column that's in that block. So then as we're satisfying a query, what we're able to do is to do block pruning, right? Essentially, we can figure out which of the blocks that are not going to participate in solving this query, and then just go after the ones that will. We'll then read them into our buffer manager before we actually need to reference them, and it's a very quick way of being able to satisfy queries. And then the last thing that's on here is Yarn integration. We've done some really clever things with Yarn. Now, I talked already about the fact that we've written our own block placement API so that when we're replicating data, we're able to indicate where that replica should be stored so that we know if you've got a primary key, foreign key relationship, we want to have that, at least one of the replicas local so that we can do local joins and avoid the need for doing any internode communication, because that's what kills database query response times, is when you have to communicate between the nodes to satisfy queries. We have a benchmark that pretty much everybody is running these days. It's not a full TPC DS benchmark. The Cloudera guys in their Impala team took a subset of the TPC DS queries. They rewrote them in SQL 92. They ran those queries against both Impala and against Hive, and they published a blog where they said, oh, Impala is 100 times faster than Hive. We decided that we would run the same benchmark and see how we did compared to Impala. What this graph represents is the number of times we were faster than Impala. So the green line is us. So if you look at that query 3, which is the first bar on the graph here, we're just over 30 times faster than Impala for running that query. And the blue lines is Impala, and they're normalized at 1 because obviously they're 1 times faster than Impala. But what you see here is for queries that involve complex joins, we're significantly faster than Impala. There's a couple of reasons for that. I talked already about the fact that we avoid having to communicate between the nodes if at all possible. And the other thing is that we have invested decades of research and development in building out query optimization technologies for distributed environments. So understanding things like, if I was to say, I want to find all of the women in the 11772 zip code who spent more than $30,000 on car parts last year, because I want to send them a special offer. Understanding if you're joining multiple tables, what is the order in which you want to join those tables? When you use our technology, you don't need to understand any of that. When you're using Impala, you need to understand the order in which you're going to be satisfying queries, because the join order the order in which you list the tables in your query is going to be the default order that it will choose for joining the tables. So understanding query optimization is something we do very well, and that's highlighted by the fact that for complex queries, we will outperform Impala by quite a bit. Now, one of the things that gets me about this particular benchmark is that when we ran the queries and we compared our times with Impala, we just have standard SQL here. You'll see that it's for anybody who's got good eyesight, it's just standard SQL. You can trust me, it's a select top 100 because the benchmark is measuring query execution time and not the time it takes to return all of the results back to the client. Selecting a whole bunch of columns from 3 tables. It's got a couple of where clauses, a group by, and order bys on here. And what you'll note on the Impala equivalent of the benchmark query is that all that gobbledygook here that I've highlighted with that blue arrow, right? What that is partition keys. So in the benchmark kit that Impala published, they actually told the query optimizer exactly where to go to find the data that it needed to satisfy the queries. So these keys are sequences of 7 digits. I can't type 7 digits, being sure that I haven't transposed 2 of them, but certainly, it's something that the typical Impala user doesn't have the knowledge of their data to be able to dictate the partition keys that they want to be used in solving the query. So, when we say we're 30 times faster than Impala, that's a very highly tuned Impala that's used partition keys for solving queries. In the real world, we hear that we're up to 100 times faster than Impala for those users that have migrated from Impala to our vector and Hadoop solution. So, real world, we love to undertake these challenges where somebody is finding that, we'll hear ridiculous things like Tableau doesn't run against Hadoop. When we look into it, it's Tableau generates some fairly complex queries that join lots of tables. Impala has a problem with it. When we run that same query against the vector in Hadoop technology, you'll see it return instantaneously. We've got sub-second response times. So it's sometimes people blame the tooling, when in fact it's the underlying technology that's having some problems there. I talked earlier about the fact that we have a 2nd generation Columnstore and the fact that we can support updates in place, right? So some of the proof of concepts that I've been involved in, they'll say, I want any updates to the data to be reflected in my reports within 30 seconds, right? So for someone who's spent their life in database, you kind of scratch your head and you're like, I'm not sure what exactly that means, because to me, if you commit a transaction and you say this update has happened, that update's happened. Any query that's executed subsequently should see that update right away. So the challenge is that HDFS was designed for data to be written once and read ever after. And that was the design goal, and they managed that pretty well. But the issue that we faced was that people want to update data that's in the database. So one example might be a bank, right, where they're somebody's entered a transaction and they've used the Canadian dollar, which is CAD currency symbol, when they meant CNY, which was the Chinese currency, I believe, and they need to fix that, right, because they've got a transaction that's in the system that's going to throw everything off for their day's reporting, and being able to provide support for individual updates in Hadoop was something that we saw a number of requests for. So we were able to take that technology I spoke of previously, that memory overlay technology, to Hadoop, and we're able to provide support for singleton inserts, updates, and deletes. These can happen concurrently. I was in that Create Hive session earlier on today about inserts, updates, and deletes in Hives, and they're talking about the fact that you can only have a single update happening on a partition at any one time. We don't have those limitations. You can have have multiple concurrent updates happening in the system. We're not trying to be an OLTP database, but certainly we've got a lot of capabilities that will give you the types of EDW capabilities that people expect in Hadoop now. So that's our positional delta trees, and if anybody would like to understand more about that technology, I'd be happy to talk to you about it later. The other thing that is a challenge on Hadoop, and you'll see a lot of Hadoop Apache projects incubating and coming out of incubation around security, right? So security in Hadoop to some extent is a bolt-on, certainly from a database perspective. So you'll see Apache Sentry, Apache Knox, some of these technologies coming on board to handle things like query auditing, right? And understanding what's happened within your system. We've built all of these capabilities into the database engine. So if we start on the list here, access control, right? So you can decide who can access what within your database at a user, group, or role level. So for an individual user, you can say, you can't access the employee table. I'm not going to let you in there to give yourself a 1,000% pay increase. You could say anybody in a particular role. So maybe everybody who's in the HR role is allowed access to the employee table. Or you could have a group, right, that says the administrators can access all of your tables. So you can decide who can access what within the database. We also have authorization, right? You need to authorize the users to access the system, and you can use a pluggable authentication mechanism like Kerberos could be used. You can use the operating system, or you can use the database. So understanding who's coming in and what they're accessing is important. Role separation. This is a challenge sometimes where you want your database administrator to be responsible for the entire system, but you don't want them to have access to all of the data in the system, right? So again, if we go back to the employee table, you may not want your database administrator knowing that the security administrator got a bigger bonus than he did this year. So you can separate the role of administering the database from actually the use of the data or access to the data within that database. So again, it shows our understanding of enterprise database deployment. Security auditing has an asterisk next to it because it's something that's coming in a release that sadly wasn't available for today. And we have a June 17th release date for our next product release, and that's a release that has security auditing. So what we were able to do here is to audit who issued what query and from where. We sometimes get people coming to us saying, I've got some user who's issuing a query that's doing a table scan that's taking forever, and I need to know who they are so I can kill that session. So we were able to produce these audit logs so you can figure that out. In the next release of the product, we will also have the ability to identify who attempted to access a table. So we go back to the now famous employee table. If you attempted to access that, our access control mechanism would keep you out of it, but the fact that you attempted to access it could trigger a security alarm that people would then come asking some questions. This becomes really important when you're dealing with things like healthcare, right? So you've got some celebrity that's in hospital getting some kind of surgery, and you've got nosy people within maybe the administration group who are taking a look to see what they can find out about that particular patient, right? So you want to have alarms going off if you can't trust that people who are being given access to certain information. You want to make sure that they can't get to it, but also that you're aware if they are trying to do anything that they shouldn't be. Encryption is important, right? So being able to encrypt data. One of the things that we get requests for is you want to have a, let's keep with the employee table, we've got our social security numbers in there, right? You don't want to encrypt your entire employee table because it makes every access to the table has this de-encryption overhead associated with it. So what you want to do is to just limit your encryption to that social security number column. And what we will do then is allow you to do just that. So you can encrypt individual tables. So when you create a table, you say, I want to encrypt this particular column, and you give it the passphrase, and then all of the data that's stored for that column is stored encrypted. We also encrypt data in motion. So all of the data that's coming from the database back to your client applications is encrypted as well. And you can go the whole hog and encrypt the entire file system. There's a performance penalty to be paid there, but it's something that we do support as well. Some of the challenges that Yarn brought us, first off, was Yarn's just not designed for long-running processes, right? So typically a database, you want it to start up and then just satisfy your queries, that you don't need to restart the database and reconfigure it for each different query type that you send to it. Yarn just wasn't designed for that, and one of the things that we needed to figure out was, how do you grow and shrink your resources on the fly? So typically in a database, you will set the size of your buffer pool, right? So that's all. If you want to keep a certain amount of data in memory, you set the size of that up front, and once that's filled, you figure out some clever algorithms for moving pages out of the buffer pool and so on. But what we have to be able to do using Yarn is to shrink that back, right, and to grow it. And we were able to figure that out, and there's some very clever technologies that went into Vector to enable that. And the other thing that we need to be able to do was to dynamically set the priority of the workload. So you can imagine when you're running a database, typically you want to give it all of the resources possible because you want your queries to run really quickly. But at the end of the month or the end of the quarter, you might have some ETL jobs that you want to get priority on the system. So one of the latest features that we're adding to the product, and that will be available on June 17th, is the ability to set the priority of the different jobs in the system so that you can say, I want to lower the database priority for right now until my ETL jobs are done, and then when the ETL jobs are done, I want you to raise the priority and regrow the resource pools that you're using. And again, we used Yarn for our intelligent block replica placement. Just to talk very briefly about some of our capabilities. When we say we're full ANSI SQL 92 support, we also have a lot of the analytic extensions like cube, roll-up, grouping sets. Merge, I heard in the Hive session, is something that everybody in Hadoop wants. We have support for merge as well. Fully ACID compliant. So again, I'm not picking on Hive, but I just happened to sit in on that session earlier. They talk about the fact that they support transactions, but they don't support multi-statement transactions, and they only support transactions with auto-commit. We support transactions. We have the begin transaction. You can commit a transaction. You can roll back a transaction. For those of you who aren't familiar with transaction, it's basically a unit of work where you want it all to complete or none of it to complete. So an example would be if I'm transferring $100 from my savings account to my checking account, I don't want to debit my savings account unless I can be sure that my checking account gets credited. So that you could think of as a transaction. We provide support for transactions in the product, and as I say, you can have multi-statement transactions. We've got the full breadth of transaction support. We also have a write-ahead log file. So should the system crash for whatever reason, and you need to go through a cold start recovery process, none of your transactions can ever get lost. We keep a log of them. If the system were to crash before a transaction were to complete, let's say we're giving everybody that 20% pay increase, and what we would do is we can unwind to the starting point for that transaction, and then you could rerun the transaction through to completion. We're Hadoop distribution agnostic, so we support all of the vendors equally well. We're on Hortonworks, we're on Cloudera, we're on MapR, also on Apache, and there have been another few Apache spin-offs that we've certified on as well. As I said earlier, we support updates in Hadoop, so that's concurrent updates. So it's important to understand that it's not just a single user that's doing inserts, updates, and deletes, but concurrent updates is something that we do pretty well. And we're kind of, I won't say we're embarrassed for the other players, but we're kind of surprised that others are talking about single updates on a partition at a time. Performance is what we're known for, but that's because we didn't understand that the importance of having a full and complete SQL implementation in Hadoop. So we have both of those, and we view those now as being equally important. I talked already about security, and I talked about the fact that we understand query optimization, and we've invested tens of decades into query optimization across all of our various database products, and that we've taken all of that research, development, and knowledge into the Vector and Hadoop query optimizer. And we also have the Yarn support I just spoke about, and open APIs. We're currently working on a project to open up access to our vector format. So if anybody wanted to read and write our data outside of the database, we're adding capabilities for other projects to be able to do that. Just want to talk very briefly about two key customer wins that we've had already. Sadly, neither of them will allow me to give you their names, but you could probably figure out who they are. The first is a sports apparel provider, and they were running their customer marketing system essentially using an online system. So they had a cloud provider who was doing all of their customer marketing for them. They then went out and they acquired one of those, map my fitness level type applications, right? So those of you who use your smartphones to track how many steps you've walked in this convention center today, or maybe you're a biker or a runner or whatever, and you track that information. They actually acquired one of those companies, and one of the reasons that they did that was they wanted to understand, if I got sneakers for Christmas, it was probably a fashion trend and not because I'm running the marathon this year. And they can tell that based upon the fact that I've put up, maybe a quarter of a mile today walking through this convention center. Somebody else who got the same sneakers at Christmas time that's put up, 50 miles a week is probably in training for something. So what they wanted to be able to do was improve their personalized marketing to their customers by joining the information they captured in the fitness tracking system together with the information that they had about the customers' buying trends. And when they wanted to do this in this hosted cloud solution, it just got prohibitively expensive. The amount of data that's being generated by the fitness tracker is massive, right? And the opportunities to do things with that is kind of huge as well, right? So if I'm running, and I'm typically running in Boston, and today all of a sudden they track that I'm running in San Jose, right? Maybe there's an opportunity to tell me that there's a great running path down here and it's best suited for a certain type of sneaker or whatever. So they can figure all of that stuff out. They couldn't do it on their hosted solution. It just got prohibitively expensive. They wanted to bring the solution in-house, and they were able to use Actian Vortex for that. So the data flow technology that I described earlier for figuring out the flow of data and exactly what you want to do and blending data from different sources and bringing it together to get to that personalized marketing experience, it was something that they were able to do for themselves, and the data volumes that our SQL and Hadoop engine can provide support for was able to easily handle the data that they had. The next one that I have here is this is a very large European bank, and what they wanted to be able to do was to adhere to some of the requirements around credit risk reporting. So, we've all, I think, been impacted by the fact that the market and the economy have tanked, particularly around the housing market. So, as a bank offers a mortgage, they need to understand the risk associated with offering that mortgage. And same with any bank transaction, right? They have to figure out what's the risk in undertaking this, and the interest rate that they charge reflects the risk. This particular bank has 2 billion risk data points that they have to analyze on a day. So they have to be able to take 2 billion data points into the database and analyze that during the workday. So a bank's workday is 10 until 4. So during that window, they have to be able to take and analyze 2 billion data points. And that was one of the challenges that they set to us. Could they get that done in a bank working day? Because they have all of these reports that they need to generate at the end of in that final hour of the day. We were able to store it not just in the 6 hours that they set out as a requirement for us, but in 1 hour and 40 minutes. So we proved that we could handle their data volume. They needed to be able to aggregate all of the data that they collected over the course of a day in less than 30 seconds. We were able to do that in 6 seconds on a 5-node cluster. And then they said, well, how do you scale? So we went to a 10-node cluster, and we were able to do it in 2 seconds. They needed us to be able to store 80 days worth of data, which was 160 billion rows. We had no problem doing that. We went beyond the 160 billion rows of data to 200 billion. We ran out of interest in proving the point beyond that, but certainly it was something we were able to do. And we were able to show them they needed to see linear scalability, and it was textbook. It's a thing of beauty. I recognize the fact we're out of time because there's a ton of people standing outside the door. So I will invite you to download our product. It's called Vortex. Vortex is the combination of data flow and our Actian vector in Hadoop. It's on the Actian website. In the top right-hand corner, you'll see that little icon that says Analyze 500 gigs for free. It's a free download, and I'd love for you to take it and to see for yourselves the rich capabilities that we provide, and to be blown away by the performance that we offer. So thank you for your time, and I hope you win a watch. Cheers.